Okay, now we will share an example for the undetermined coefficient to solve the particular solution. Okay, so example for undetermined coefficient to find the particular solution. Okay, so we have our mass spring damping system. We will use the same examples before we solve the homogeneous solution. Right now, we will solve for the particular solution. So that is y prime equals to ay plus g. And you have the a is the coefficient part, 0, 1, -2, -3. You have the g part, which is 0, 10, e to the -2t. And you have the homogeneous solution, which is c1 e to the -2t plus c2 e to the -t, -2 c1 e to the -2t minus c2 e to the -t. How to construct these homogeneous solutions? We solve the eigenvalue and the eigenvector problem. We get eigenvalue. One is -2, the other one is -1. So when the eigenvalue equals -2, we get our eigenvector is 1, -2. The other eigenvector, when lambda 2 equals -1, we get 1, -1 for the eigenvalues and eigenvectors. Then we are trying to use undetermined coefficient to solve the particular solution, right? So through the general rule, the particular solution should look like, the g plus all its derivative. And this g is your Faustin function. And our Faustin function look like e to the -2t. So our through the general rule, our particular solution should look like something times e to the -2t. So we can say k times e to the -2t. Okay. And e to the -2t derivative will be itself times some constant. So it will combine into the k part. Doesn't matter. Then through the special rule, is that apply to this problem? So this e to the -2t means this -2 part is the same as our eigenvalues, right? Then it's applied for our special rule because that's saying if your homogeneous value has the same part as combined as the same part to the particular Faustin function, then we need to rewrite our particular solution format, which will be alpha x1 t plus z times e to the -2t because they share the same term. And this x will be associated with this eigenvalue, which is the eigenvector 1, okay? Then through this file, expression of the yp, what we can get is yp prime. So yp prime will be equals to -2 alpha x1 t e to the -2t plus alpha x1 e to the -2t minus 2z e to the -2t. So that is derivative from this equation directly. But we also know that yp prime will be equals to ayp plus g. And what is our ayp? So the ayp will be a alpha x1 t e to the -2t plus a z e to the -2t plus g, Faustin function, which is 0, 10 e to the -2t. Okay, So that is based on whatever the definition for y prime, we can also get yp prime equals a yp plus g. Then this equation one and the equation two should be the same, because they all equals to yp prime. So we can write negative 2 alpha x1 t e to the negative 2t plus alpha x1 e to the negative 2t minus 2z e to the negative 2t. That is equals to a x1 alpha t e to the negative 2t plus a j e to the negative 2t plus 0, 10 e to the negative 2t.